In this standard, you're going to learn the key features and characteristics of the graph of quadratics. The standard is IF 4 and 7. Use tables, graphs, and verbal descriptions. Interpret key characteristics of a function with quadratics. You're also going to learn about maximum, minimum, symmetries, and end behavior. A quadratic equation has the form y equals ax squared plus bx plus c, where a, b, and c are considered constants. When modeling a moving object, x is usually the time that the object has been moving, and y is the distance it has traveled in some directions. Again, your equation is y equals ax squared plus bx plus c. Standard form, f of x equals ax squared plus bx plus c, where a does not equal 0. Factored form, a times x minus r times x minus s. And then vertex form. Now all of these will come back when we do factoring and whatnot. A parabola. The graph of a quadratic equation in standard form, y equals ax squared plus bx plus c, is a U-shaped curve called a parabola. If the leading coefficient, a, is positive, the parabola will open upward. If the leading coefficient is negative, the parabola will open downward. Parabolas are graphs of quadratic functions without domain restrictions, meaning all x values will be shown because domain and x values are the same. Maximum is the highest point on a graph, and the minimum is the lowest point in a graph. Now it depends on what type of quadratic equation you're dealing with, if you have a maximum or a minimum. Also, vertex. Vertex is the maximum or minimum of a quadratic function. It is the y-coordinate of the vertex of its graph. The vertex is the lowest or highest point. Again, the y-coordinate of the vertex of its graph is the maximum or minimum. If a is greater than 0, then the parabola opens upward. It has a minimum value. If a is less than 0, the parabola opens downward and it has a maximum value. That is imperative. If a is greater than 0, you're looking for the minimum. If a is less than 0, you're looking for the maximum value. This is an example of a quadratic. Quadratic equation, as you can see, is a U-shaped form. As you can see, we have the vertex right here of this parabola, and that's where I'm going to talk about the axis of symmetry. The graph of a quadratic function is a parabola. The axis of symmetry of a parabola is a vertical line that divides the parabola into two congruent halves. The axis of symmetry also passes through the vertex of the parabola. The x-coordinate of the vertex is the equation of the axis of symmetry of the parabola. Now, let's do one together. X squared plus 4x minus 5. So I'm going to go to the y equals part of my TI-83, and I'm going to pop that in, and I'm going to get the graph. Now, I'm actually going to graph it on here. -1, -8, can't do that one, but 0, -5, I can. -4, -5. -2, -9 is actually our vertex. -3, -8. -1, -8. 1, 0. -5, 0. -6, 7. 2, 7. If you're using your TI-83, that's, again, it'd be drawn a little better, but That's what the parabola will look like. As you can tell, the vertex is -2, -9. Since this is a positive 1x squared, that means we will not have a maximum. We will have a minimum. The minimum is, let's go back a slide. The minimum is the lowest point on a parabola. The maximum or minimum of a quadratic function is the y-coordinate of the vertex. Okay, so now, again, the vertex in this equation is -2, -9. That means the minimum is -9. The domain is all real numbers because every x value will be represented. However, your y values will not be represented below -9. So what that means is this. The range is greater than or equal to -9. So y is greater than or equal to -9 because below -9, it can't be represented. The x-intercepts, where it's hitting the x-axis, are -5 and 1. Your y-intercept is -5. Now, interval of increase, interval of decrease. The interval of increase is where I have a positive slope. And in this case, x is greater than -1. An interval of decrease is x is less than -1. A -2, rather. -2. Now, I also have a table here that I could have filled in to help me. -5, 0. -4, -5. -2, -9. -1, -8. 0, -5. 1, 0. And 2, 7. Now let's do one that has a negative a. Go back, clear the graph. -x squared plus 6x minus 5. Zero, -5, 1, 0, 2, 3, 3, 4, 4, 3, 5, 0, 6, -5. As you can tell, the y values are going to be the same in certain places. So that right there should show you your vertex is 3, 4. Now let's graph it. 3, 4, 0, -5, 1, 0, 2, 3, 4, 3, 5, 0, and 6, -5. Domain, all real numbers. Range, y is less than or equal to 4. Because anything greater than 4 will not be represented in the range. Remember, range is your y value. X-intercept, where the x is 0. I apologize, where y is 0. The x-intercepts are 1 and 5. That's where it's hitting. Y-intercept. In this case, the y-intercept is -5. Interval of increase. Interval of increase. X is less than or equal to 3. An interval of decrease, x is greater than or equal to 3. The maximum y value that you will have is 4. And there is no minimum because it is a negative graph.